In this lesson, we're going to look at the quotient of powers property. So another word for quotient is division. So the essential question, how can you divide two powers that have the same base? We're looking at dividing and applying the rule for dividing powers. So in activity 1 here, you're going to complete the table and you'll end up finding the quotient of powers rule. So we'll start off together. So we have the quotient of 2 to the 4th divided by 2 to the 2nd. So remember, the numerator, we're going to write that out with repeated multiplication. In expanded form, we're going to write the numerator first. 2 to the 4th would be 2 multiplied by itself 4 times. So 2 times 2 times 2 times 2. Okay, then for the denominator, I have 2 to the 2nd. So I'm dividing that by 2 times 2. That's 2 to the 2nd. Okay, then what I have to look at is simplifying this expression here. Now, remember, anytime I have a number and divide it by itself, it equals 1. So this 2 divided by 2, this pair here, I'm going to cross that out because that's equal to 1 whole. Okay, then I'm going to look at the next 2 divided by 2. That equals 1 whole. Okay, I have nothing else that I can reduce with. So in the numerator, I have 2 times 2, which would be 2 to the 2nd power. And in the denominator, I don't have any numbers, but I can't put a 0 down here because that would make it an undefined fraction. Remember that if you need a placeholder, it's always over 1. So 2 to the 2nd over 1. So then to write this as a power, I have 2 to the 2nd power, and we're going to leave it like that. We don't need to find the value of it. Okay, let's take a look at the next one and then see if we can notice some patterns here. So I have negative 4 to the 5th in the numerator. So that would be negative 4 times negative 4 times negative 4 times negative 4 times negative 4. So that's negative 4 to the 5th. Then I'm dividing it by negative 4 to the 2nd power. So in the denominator, negative 4 times negative 4. That would be negative 4 to the 2nd. Okay, now when I reduce, negative 4 divided by negative 4, that's 1 whole. And then I have another set, negative 4 divided by negative 4 is 1 whole. Okay, so in the numerator I had 5 4s, negative 4s. In the denominator I had 2 negative 4s. So let's see what we're left with. 1, 2, 3 negative 4s. So I have negative 4 to the 3rd. And then over, nothing in the denominator, so over 1. Okay, so for my power, I just have negative 4 to the 3rd. Make sure you put the parentheses around to show the negative goes with the 4. So I want you to start thinking about how do these exponents, 5 and 2, relate to the exponent for the answer, which is 3. Next one, 7 to the 7th. So this is going to get kind of redundant here because we're having to write it out in expanded form, but hopefully by the end of the lesson, you'll have come up with a shortcut, which would be the rule. So 7 to the 7th in the top. 7 times 7 times 7 times 7 times 7 times 7 times 7. Okay, that's 7 to the 7th. Then dividing it by 7 to the 3rd. 7 times 7 times 7. Okay, so when I look at reducing, 7 divided by 7 is 1. When I have another pair, 7 divided by 7 is 1. 7 divided by 7 is 1. Okay, what we're left over with in the numerator would be 1, 2, 3, 4, 7. So 7 to the 4th. And then over 1. Nothing left down here. So 7 to the 7th divided by 7 to the 3rd was 7 to the 4th. So think about these exponents. 7 and 3, how does it relate to the 4? Okay, I'll do another one with you, and then you're going to do the rest of them on your own, and you'll check your work. So next one, 8.5 to the 9th. So I'm really going to have to write out quite a few 8.5s here. 8.5 times 8.5 times 8.5 times 8.5 times 8.5 times 8.5. That's 6 of them. 7 of them, 8 and 9 8.5s. Then I'm dividing it by 8.5 to the 6th. 0.5 times 8.5 times 8.5 times 8.5. Here's the 5th one and the 6th one times 8.5. So now when I start to reduce, remember 8.5 divided by 8.5 is 1. So that makes 1. Okay, and you can see 6 of them on the top and 6 of them on the bottom reduced to equal 1. So now what I'm left with in the numerator is I have 8.5 to the 1, 2, 3 third power. And remember, it's over 1. I don't need to write the over 1 for my power. Okay, so 8.5 to the 9th divided by 8.5 to the 6th equaled 8.5 to the 3rd. Okay, what you're going to do for the rest of the table, you're going to fill out the rest of the table with the repeated multiplication and the power. When you are done, push play and you'll be able to check your answer. So go ahead and push pause right now. Okay, so you can compare your table with what I have for you on the screen. Make sure we both have the same powers. And now we're going to try to look at a pattern here to notice what the rule would be for dividing powers. So it says describe the pattern in the table, then write a rule in the box below for dividing two powers that have the same base. So if we kind of look at the last half of the table here, I'm looking at the powers of 8 and 5 and how that's related to 3. Okay, or how does 12 and 4 relate to 8? Next one, how does 7 and 5 relate to 2? And last one, how does 4 and 1 relate to 3? So the operation that would make 8 and 5 relate to 3 would be subtracting. If I do 8 take away 5, I end up with 3. Okay, let's see if that works for the next one. If I do 12 take away 4, that's 8, and my exponent is 8. Okay, next one, negative 5 to the 7th divided by negative 5 to the 5th. So if I do 7 take away 5, the exponent is 2. And if I do 4 take away 1, the exponent is 3. So what we see happening here is even though we're dividing powers, the rule is to subtract the exponents. So top minus bottom equals the exponent on the power. Okay, that's very important that you keep in your head, okay, I am dividing the powers, but I'm actually subtracting the exponents. So let's go ahead and fill in the rule right here, dividing powers property. When two powers with the same base are divided, the base stays the same and the exponents are subtracted. And it's super important that you note it's always numerator minus denominator. Okay, you have to go in that order. Sometimes the larger number might be in the denominator, and we will tackle that in a little bit. Okay, now we're going to use the rule to write the power in the second column, and we'll simplify in the third column. So you are not going to have to write expanded form out anymore, which will make things a lot less tedious. So for the first example, we have 6 to the 5th divided by 6 to the 2nd. Remember, we look at the exponents 5 and 2 and we subtract them. So 5 take away 2 is 3. So my power then would be 6 to the 3rd power. For simplified form, I need to figure out what 6 times 6 times 6 is, and that would be 216. Okay, simplified form would be like the value of it. Next one, negative 3 to the 11th divided by negative 3 to the 3rd. So look at the exponents, 11 and 3, subtract them. 11 take away 3 is 8, so I would have negative 3 to the 8th power. Now, you probably don't want to type in the calculator negative 3 times negative 3 8 times, So I'm going to show you a little bit shorter way with a button on the calculator. So if you have a calculator like this or the one from the classrooms, you're going to look for, first of all, the 2 parentheses buttons because you need to put -3 in parentheses. So you can go ahead and type in -3. You have to put the parentheses around it first as you type it. And then to raise it to a power, you're going to look for this button here. It looks like a little mountain that's kind of raising things up. So you can type in that. And then to the 8th power, because we wanted it to be to the 8th power. So when you type that in, it'll give you the answer for -3 to the 8th. On this computer calculator, put your parentheses, and then you have to type 3 negative, and then to raise it to a power, you do this X to the Y button, and you can see it made that little mountain there, and type in 8 then, and then you get your answer. So 6,561. Next one, 12 to the 19th divided by 12 to the 17th. So remember, subtract the exponents. 19 take away 17 is 2. So that would be 12 to the 2nd. And we know 12 times 12 is 144. Next one, 3.5 to the 9th divided by 3.5 to the 5th. Look at the exponents. Okay, the rule for dividing them says subtract the exponents. 9 take away 5 is 4. So 3.5 to the 4th power. So you will figure out what that equals. 3.5 to the 4th power equals 150.0625. Now I'll leave it as 0.06. Next one, 16 to the 9th divided by 16 to the 8th. So you're thinking in your head, 16 9 times on the top, 16 8 times on the bottom. Remember, when in doubt, you could write it out and cancel out the pairs that equal 1. But I'll subtract the exponents. 9 take away 8 is 1. So I have 16 to the 1st power, which is just 16. Next one, 7 to the 5th divided by 7 to the 5th. So this should seem familiar to you from 10.4. When I subtract my exponents, 5 take away 5 is 0. So I have 7 to the power of 0. Anything to the power of 0, remember, is 1. And next one, -2 to the 88th divided by -2 to the 82nd. So you're not going to want to write out -2 88 times and 82 times. That's a lot of tedious work. Remember, subtract your exponents. 88 take away 82 is 6. So I have -2 to the 6th power. Okay, and then when I go figure out the value of that, -2 to the 6th power is 64. And it makes things a lot shorter than writing it out in expanded form. And last one here. We have 10 to the 2nd divided by 10 to the -3rd. So this one might look a little bit different, and you should notice that there's a -3 for an exponent, and it's in the denominator. So it's going to work the same way though. Look at the exponents, 2 and -3, and you're going to subtract them. Be careful though when you subtract on this one. You're really doing 2 minus, because I'm subtracting top minus bottom, -3. Okay, and what you should notice here is that when I subtract a negative, it's really adding. Minusing a negative is adding. So 2 minus -3 is really 2 plus 3, which is 5. So when I take my 2 for my exponent in the numerator minus -3 for the exponent in the denominator, it ends up adding. So the exponent will be 5. So it will be 10 to the 5th. And 10 to the 5th is 100,000. Okay, for the last few examples here, we're going to use multiple rules of the power rules here because we might have some multiplying powers, we'll have some power to a power, and we'll have some dividing powers. So remember, you're either probably going to add, subtract, or multiply the exponents. You've got to keep that straight. So it says, looking at negative exponents, write each expression as a power using positive exponents only. So for A, We have 5 to the negative 6 divided by 5 to the negative 12. Remember, look at the exponents, negative 6 and negative 12, and we're going to subtract them. So we're going to do the numerator exponent minus the denominator exponent. So negative 6 minus negative 12. Okay, top exponent minus the bottom exponent. Be careful when I subtract negative 6 minus negative 12, the minus and negative really is adding. So negative 6 plus 12 is positive 6. So that would be my exponent, 5 to the positive 6th power. Okay, now B, notice we have these parentheses, so we need to take care of the top and simplify the top first. So I'm multiplying these two powers together, but really the rule says that I need to add the exponents. So I need to add 3 plus negative 15. Well, 3 plus negative 15 is negative 12, so then in the numerator I would have 8 to the negative 12th. Okay, and then I'm going to bring over 8 to the third, dividing by 8 to the third, and now I'll simplify this part here. 8 to the negative 12th divided by 8 to the third. So when I'm dividing powers, the rule is to subtract the exponents. So I need to do negative 12 minus 3. Okay, negative 12 minus 3 is negative 15. So that's going to be my exponent for the base of 8 that stays the same. So I have 8 to the negative 15th. However, we need to write with positive exponents. So I need to change this into be a positive exponent. Remember how to do that? Normally it's over 1. So I'm going to take the reciprocal of it. I'm going to flip the numerator and the denominator, and then the exponent of the negative 15 will be positive. So I have 1 over 8 to the 15th. And that is your final expression. And last one for C. So I have some parentheses here that I have to simplify, and then I have to raise that to the negative third power, and then lastly divide it by 2 to the negative ninth. So I'll simplify the parentheses. 2 to the 11th times 2 to the 5th. Multiplying powers, the rule is to add the exponents. So 11 plus 5 is 16. So this simplifies to be 2 to the 16th. But then I need to raise all of that to the negative third power. So when I take a power to another power, the rule is to multiply these two exponents. So 16 times negative 3 would be negative 48. So the numerator simplifies to be 2 to the negative 48th. So that's everything on the top would equal 2 to the negative 48th. And then I'm going to bring down dividing by 2 to the negative 9th. Okay, so now I have 2 to the negative 48th divided by 2 to the negative 9th. I need to subtract the exponents because that's a rule for when you're dividing powers. So I'm going to either use my calculator or think what's negative 48 minus negative 9, because top minus bottom here. When I subtract a negative, it's really adding. So negative 48 plus 9 is negative 39. So that will be my exponent, 2 to the negative 39th, but we do not leave things with negative exponents. So I need to take the reciprocal of it. So I flip it, I put a 1 in the numerator and 2 to the 39th in the denominator, and that is your final expression.